All right. So I'm going to share my Minitab screen. So participants here, can you confirm my screen visibility? Is my
Yes,
Minitab
sir.
screen? Yeah.
Yes,
Yes.
sir,
Sir.
it is visible.
Yeah. So one of you, can you read what is the heading for column number 1 and column number 2?
Weight gain, calories consumed.
Very good. So we are going to study whether there is any relationship between weight gain and calories consumed. Weight gained and then calories consumed. Please tell me which is a y variable here, which is an x variable here.
So calories consumed will be the X variable.
X, weight gained is Y.
Very
And
good.
weight
You
gained
all
is
have
Y.
understood the tool correctly. Y equal to f of x, right? This thinking is very, very important. Y equal to f of x. Very good. Now I want to really understand for a particular individual on whom we did the experiment, is there a relationship between weight gain and calorie consumed? And I have about 14 readings, 14 set of reading, right? So in order to understand the relationship, you can think of these tools. First, the basic tool is scatter diagram. Then you can move on to correlation. Then you can move on to regression, right? This is what we are going to do. So go to graph. All of you, can you see scatter plot? The first option.
Yes, sir.
What is the description here? Scatter plot.
Examines the relationship between Y variable and X variable.
Yeah. Any project, any situation when you are working, you want to understand relationship between two variable. One is X and another one is Y. But the requirement is both variables should be of continuous data. Both variables should be of continuous data. Hope all of you know clearly the meaning of continuous data. So now I can go for scatter plot. You know why I can go for scatter plot? Do you think both the variable here X and Y are continuous? Yes or no, all of you?
Yes, sir.
Yeah. So I'm going for the scatter plot. Graph, scatter plot. There are different types of scatter plot available. Let us choose the simple scatter plot. Give OK. And then it is just asking you which is your Y variable. You all have already confirmed that Y variable is weight gain. And X variable is calorie consumed.
Calories consumed.
So I'm just giving OK. It's all done. You will get a scatter diagram. Now all of you, are you able to make out anything by looking at the graph? Look at here, the X variable, calorie consumed, Y variable, weight gain. In scatter analysis, correlation, and regression, the X variable is known as predictor variable. What is the name of X variable? Predictor variable. And similarly, the Y variable is known as response variable. So what is the other name for X variable?
Predictor variable.
Predictor variable. And Y variable? Response variable, right? So these terminologies are normally used in scatter analysis, correlation, and regression. So now looking at the dots, can you tell me what are these dots represent? People here, participants here.
There is a direct relationship.
Positive relationship.
Okay, very good. Positive relationship, which means
By the increase in consumption,
Weight
calorie
increases, calorie increases, you will increase your weight also.
yeah, when I keep on increasing my calories consumption, I could see an increase in the weight gain. That means the relationship is positive. Relationship is
Positive.
positive. Increasing the X causes the increase in the Y. And these dots actually represents the value of weight gain. Please, all of you note. These dots represent the value of weight gain for different values of calorie consumption.
Calories.
For different values of calories. So now approximately, can you see all these points forming a pattern of line? Is it an approximately a line?
Yeah.
Yeah.
So you can call this relationship as linear relationship
Hmm.
because it is approximately a line, right? So I'll also show you that line, graph, scatter plot by switching to the third option of scatter diagram with regression. Give OK, same y variable, same x variable. Can all of you see a red color line now?
Yes, sir.
This line is known as regression line. This line is known as regression line. That is nothing but the pattern with which the points are, aligned is a straight line. So this line is known as regression line. But actually, if you look at the way the points are arranged, if I connect them through the points, it won't be a straight line. Am I right?
Yes, sir.
It won't be a straight line. But I'm still assuming that the pattern is a straight line. So that means my line has got some assumption, isn't it? Definitely there will be some error in your assumption. That error here is called as residual. The error here is called as residual. The residual is nothing but the distance of each of the point from your regression line. Suppose, for example, the third point. Look at my pointer. Can you comment how is this point located? Is it located very close to the line or away from the line?
Close to the line.
Very close. In fact, it is touching the line. The residual is close to 0. We want the residual to be minimal. Fulfilling this condition, you have to imagine a line. Now, do you understand how this line is assumed? You can't say, sir, this is my line. This is my regression line. That means you are not respecting this principle. This is called principle of least square. This is called principle of least square, meaning the residual must be least. All of you get my point?
Yes, sir.
If the residual is least, then this line can speak the reality. What is happening in real time, that is captured in your data. And that is now visualized as a line. So this line can help you to understand the real problem you are trying to solve. That means it is nothing but the line is the mathematical model of the problem. The line is nothing but the mathematical model of the problem because any line will have an equation. Am I right? Yes or no? Any
Yes.
line will have an equation, the mathematical equation. What is that mathematical equation?
Y is equal to mx plus c.
Very good. Y equal to f of x. And here exactly it is y equal to mx plus c. So once you know it is y equal to mx plus c, we all have studied this, right?
Yes.
And then, this equation is known as regression line. In order to write this regression line yourself, you just have to know what is the value of m. You just have to know what is the value of c. All right. So now the first tool we used here is, what is the name of this tool? Scatter plot.
Scatter.
This is one of the 7 basic QC tool. So let us plot a scatter plot for another situation also. I'm going to the data source again. So let me erase this. Oh, I'm erasing this. All right. So now another situation. The another situation is hydrogen content and porosity. Hydrogen content in your molten metal and porosity in your final casting. So in this case, we are going to study the relationship between hydrogen content and then porosity. Porosity means, some kind of holes,
Bubbles.
bubbles or holes
Or pinholes.
inside your solid casting.
Material.
Yes.
Solid
Yes.
casting should be fully solid, isn't it?
Yes.
But
Yes,
there
sir.
could be some air bubbles or, people call it holes inside. You come to know there is a hole only when you machine it. If you machine it, you come to know there are some holes, right? Some companies, they conduct some kind of testing, non-destructive testing, to check whether the casting is porous or good. And now porosity is a problem, and then it is believed that hydrogen content is the cause. That means this is the X variable, this is the Y variable. Somehow you manage to measure the porosity for different values of hydrogen content. And you want to study the relationship, whether there is a relationship, right? Because you never thought that the amount of hydrogen content can cause porosity, but your brainstorming team have suggested that hydrogen content should be allowed to vary. It should be at the exactly required level, preferably with a smaller range. But now see here, it varies from 0.18 to 0.28. You see here, 0.18 to 0.28 is a wide range. And people are saying that this could be the reason for the porosity. So we are trying to visualize this thing in the form of a scatter plot, this time directly with the regression. We're giving OK. And now the Y variable is porosity and the X variable is hydrogen content. Now, can you tell me, but I have straight away chosen the regression line. So let me remove that regression line. Porosity first, hydrogen content. Now, can you tell me, is there a relationship between X and Y here?
Very difficult to tell.
Yeah,
No.
very difficult to tell, right? So, in order to overcome this, because, it looks some kind of relationship, because you can see as I move from left to right, I can see my points moving from, moving upwards, isn't it? So there is some relationship. So to overcome this, you can actually consider going for the another analysis called correlation. Another analysis called correlation, right? So let us do the correlation for both cases one by one. The first case, weight gain and calories. So stat, basic stat, correlation. So the description goes like this. Correlation will measure the strength and direction of the linear relationship between two variables. You have already seen in the scatter diagram that the relationship is linear as far as the calorie consumption and weight gain is concerned. So I'm selecting this. The two variables are weight gain and calorie consumption. I select this. And there are two methods here. And one method, the familiar method is Pearson correlation. Choose. And you can give OK. Once I give OK, Minitab has given me the Pearson correlation coefficient. Pearson correlation coefficient, which is nothing but a small r. How much is this? 0.97. The formula r is actually a function of your data. Depending on the data only, r value is generated, right? And how this is calculated? X bar, Y bar. All of you, do you know what is X bar, Y bar here?
Yes, sir.
X bar is average of the X data, Y bar is average of the Y data. Similarly, do you also know what is SX, SY?
Sorry?
Standard deviation.
Standard
Very
deviation.
good. The standard deviation of your data.
X and Y.
X data and Y data. And then there is N. What do you know? What is N?
Number of readings.
repetitions,
Number
yeah,
of pairs of
14.
data. The number of experiments you have conducted, right? So
Right.
once you know all these things, R will be calculated. Please note, the R will vary from -1 to +1. R will vary from -1 to +1. If R is equal to 0, it simply means there is no correlation. Krishnamurthy, please mute yourself. Mute yourself. Yeah, mute yourself. You can be on video, right? I have no problem you keeping your video on. Only mute yourself, and then you can press the space bar during, when you want to talk. So there is no correlation, which means there is no linear relationship. All of you understand the meaning of R becoming 0? Yes? Come on. All of you, do you understand or not? R equal to 0.
Sir, R equal to 0.
R equal to 0 means there is no correlation. That means there is no linear relationship. That means...
Sir, have you told no linear relationship?
How?
How?
See, earlier I have shown you graph, right?
Yes, sir.
Here is the graph. Here is the graph. What is the relationship? What is the relationship here? Linear, right?
Yes, sir.
In this condition, you calculate the R value. How much is the R value? You see here?
0.97.
0.97. But now I'm trying to educate you. When R equal to 0, there is no relationship. I mean, there is no linear relationship. But when R equal to 1, the relationship is perfect linear relationship. Perfect linear relationship. In our case, currently, R equal to how much? 0.97. That means strong relationship. Because close to perfection, isn't it?
Yes, sir.
You can even call
Only
it...
0.3.
Yeah.
0.03.
See, why this formula is created? Because some people are good at reading the graph. You read from the graph and you can straight away comment. What is the relationship? Strong, positive relationship. Am I right? Strong, positive correlation. But if you are having problem reading this, and now this is coming to help. This is just a formula. This is just going to help, help us directly understand. So R can be 0. 0 means, what is the meaning of 0? No correlation. 1 means perfect. +1 means perfect positive. -1 means perfect negative. Now please note, R value from 0 to 0.4, we are going to consider the correlation as weak. R value from 0.4 to 0.7, we will consider the correlation as moderate. R value 0.7 to 1, we'll consider the relationship as, the correlation as strong correlation. And if it is exactly equal to 1, that's the time we will use the word perfect. All of you are with me on this?
Yes, sir.
And whenever it is 0, 2 plus 1, your correlation is positive. Your correlation is positive. Whenever it is 0 to -1, your correlation is negative. Clear? So this first case, we do not have any problem because the visual also confirming the correlation, formula also confirming the correlation. But the second one, the visual is a problem. Can you see here, all of you?
Yes, sir.
Visual is a problem. Let us do the correlation study now. Stat, basic stat. Where should I go? Correlation. Now I should just choose the two variable X and Y, hydrogen content and porosity. I'm giving OK here. Now tell me, what is the R value?
0.65.
0.6. When you know your R value is 0.625, which is Pearson correlation coefficient. What is your conclusion? What kind of relationship it is?
Moderate.
Moderate positive.
Moderate, very good. Moderate positive correlation. So that's the advantage of you having a formula. You can always read from the graph directly. You can also read through the values. So
Sir.
whatever is convenient to you.
Sir,
Yes.
I'm audible.
Yeah, you
Sir,
are
what is
audible.
the R represent is the slope of line is positive. What is means exactly?
No, R is the, I think, intercept, na?
No. What is that I have written? Can you see, Shubham? Can you see what I have
Yes,
written?
sir. Yes, sir. Yes.
R is derived from your data. R is derived from your data. And there is a formula. And using this
Okay.
formula,
So
Pearson,
this is nothing but it shows how many points are above the line or how many points are below the line, and that will give a data. Is like that, sir?
no. Wait.
No. Okay.
So wait. I'll just take you to the formula. Then you might have a good idea. Since you wanted the formula, I'm just trying to show. So all of you, do you remember I have given you a sigma level calculator file?
Yes, sir.
Please keep it very safely with you. That will, bring clarity in many situations. See here, I have already did some working here. Let me see whether that is available here. Pearson correlation coefficient tab. Shubham, can you see here?
Yes, sir. Yes, sir.
Weight gain, Y variable, calorie
Right.
consumption, X variable, X bar
Right.
calculated, Y bar calculated, standard deviation of Y calculated, standard deviation of X calculated. Now,
Right.
X minus X bar. You know what is X minus X bar? Deviation from the mean value.
Right.
Deviation from the mean value divided by standard deviation of the X variable.
Variance.
Yeah, standard deviation of the X variable. Similarly,
Right.
deviation from the mean value for Y value and that deviation divided by standard deviation of Y.
Right.
So now the D and F, they are multiplied together to get this value. Clear?
Okay. Right, sir.
Then all these values are summed up. All
Right.
these summed up, that gives
12.6.
12.6. And this
Right.
value is divided by the degree of freedom, which is n minus 1.
Degree of
N
right,
here
sir.
is 14, so n minus 1 will be 13.
Degree of freedom
Now that is giving 0.96.
is nearby
0.969. Right? And
Right.
now, yeah. And now, what is that? Yes. Yeah. So R value is 0.97. Can you see 0.97 coming?
Right.
This is how the 0.97 is coming. But how do you want to understand? You understand in your own way, right? But this is a
Right.
method created by Pearson, who is a statistician, right? He created, and his thinking is, to find out how linear the line is. Do you understand?
Yes, sir. Yes, sir.
If all of you stand in a perfect straight line, and I calculate R, you know what will happen to the value of R?
It will be
1.
It is one.
It will become 1. In that manner only the formula is designed. If you all stand in a zigzag manner and somehow I make a data out of it and apply here, then R will fall down, isn't it? It will slow, it will approach 0. Because all of how are you standing? They're all standing in a zigzag manner. So similarly, depending on the position of the points, the R value is coming to help. This is helping you to understand how the relationship will be directly by looking at the R value. You don't have to look at any graph, but
Right, sir.
you can always refer both. That's a good idea. So I want all of you to just go through this Excel on your own, so that you can gain a better understanding about the logic of Pearson correlation coefficient. Clear?
Right, sir.
Now, Going to mini tab again, right? Mini tab.
Thank you, sir.
Yeah. My mini tab is here. So now R equal to 0.97. The same R value is here. How is this going to be helpful for me? For that purpose, I want you to square this R. When you square this R, it will become coefficient of determination. Can one of you square this value for me and tell me how much it is coming to be? Point 0.97 multiplied by 0.97.
1940.
0.94.
0.94.
Very good. This 0.94 is giving me another information. 94% of the changes observed in the y variable are due to the changes made in the x.
X variable.
Can one of you read out this statement again?
94%.
94% of the changes observed in the y variable are due to the changes made in the x variable.
That means x variable is majorly responsible for the variations in y variable. Am I correct? Yes or no?
Yes, sir.
Yes, sir.
Means x variable is majorly responsible for the variations in y variable. That again means x variable is the root cause. Right? And in this case, x variable is the single root cause. Am I right? X variable is the
Right, sir.
single root cause. Why do I call it single root cause? Because only 6% of the variations are not explained by the what do you call by the variations of x variable, or otherwise you can say you have assumed a mathematical model. You have assumed a mathematical model. What is your mathematical model? Simple linear model. Am I right? You have assumed a
Right.
simple linear mathematical model. So according to your assumption, 94% of the variations in y are due to the variations in the x variable. And this model is a perfect model, and this is the single root cause. This particular problem can definitely be solved just by working on the x variable you are studying. Right? Now let us do the same analysis for the other situation. See here, hydrogen content and porosity, all of you. Can you all see another set of data? Yes?
Yes, sir.
Yes, sir.
Yeah, please guide me through the path here, Minitab path. Which tab I should use now?
Graph.
Graph. Correlation.
Where is correlation here?
Um,
Nay, scattered plot.
Sir, start.
Stat.
Okay.
Stat.
Basic
Regression.
statics.
Basics.
Basic statics
Stat, basic
Basic
stat.
statistics.
and
Correlation.
correlation.
Very good. This is the root. Now you click this. Now I will remove this set pair of data. I'll put this pair now. I'm giving OK. And now this is 0.625, right? This is 0.625. And now same manner, R square. Can one of you tell me 0.625 multiplied by 0.625? So how much it is?
1390.
0.625
0.39?
390.
Okay, 0.390.
Hmm.
That means, what is your understanding now? Can one of you frame the statement like how I framed the statement earlier?
So 39% of the changes are responsible, or the X variable is responsible in the Y
Or
variable.
changes in
caused
Y
by-
variable are
Are caused by the X
due
variable.
to the
Changes
changes in
In
the
X variable.
X variable. Do you now understand the meaning of the statement?
Yes.
Y is changing and it depends on the X to the extent of how much?
39%.
That means remaining 69% of the time, the variations can be due to some other factor.
Mother.
In this situation, can you say this is the only root cause?
No, sir.
Your Y depends on other factors as well. So, the X factor under study is one of the root cause. Am I right? And not the,
Only root cause.
yes, very good understanding. So this is how we understand the sufficiency of the factors. Right now, the factors you considered for the second problem is not sufficient. Why the other factors are not included in your mathematical model? Your people have failed to consider other factor, isn't it?
Hmm.
Maybe your fishbone analysis, brainstorming, somewhere it is lost. Am I right? Either it is not listed in the list of X factor or it was not brought into the high impact, high control quadrant. Yes or no?
Yes, sir.
Because you are only identifying the factors, then identifying the critical factors, then validating the critical factors. And you thought that this, certain factors are not critical, but actually there are other factors which are also critical. So now do you understand something about sufficiency?
Yes, sir.
So, as far as the second situation, one factor is not enough to fix the porosity. Am I right?
Yes, sir.
Just working on one factor and trying to fix the porosity problem is not a correct idea. But in this situation, first situation, working on calories consumption to fix the problem of weight gain is really a good idea. Clear?
Yes, sir.
Now let me also show you how the regression equation will look like. All of you are with me on this so far?
Yes, sir.
Yes.
All right. Now let me show the regression equation. And already Swapnil has told that the equation is going to be y equal to mx plus c. The famous equation. Y equal to mx plus c. Now what is m here?
Slope.
Slope of the line. What is the meaning of this? How much impact on y? How much impact happens in y? Or how much impact in y for unit change in x? Do you understand the meaning?
Yes, sir.
What will happen? How much change I can expect in the y if I make an unit change in my x? Let's say, for example, the equation is y equal to x. Now tell me, if x equal to 1, what will be the value of y?
1.
y equal to 1. Now I am going to increase the x by one more unit. If I increase the x by one more unit, what will be the new value of x? X will be 2, right?
Yes.
Can you see x is increased by 1 unit? Now what happens to y?
Y is also 2.
Now how much value y increased? Y also increased by 1 unit.
Yes, sir.
When I increase x by 1 unit, y also increases by 1 unit. This is what you are seeing here as m. In this equation, y equal to x. What is the value of m?
1.
Very good. The meaning of 1 is, when I increase x by 1 unit, y will increase by 1 unit. All of you are with me?
Yes, sir.
If m equal to 0.5, can somebody tell me the meaning?
Of
Come on. If I increase x by 1 unit, what will happen to y?
It will increase.
It was half. It will be half.
It will increase by.
No, it will be half.
0.5 unit.
Yeah.
Do you understand how the m is helping you? Ultimately, what is your project? Your project is you want to optimize y, right? Yes or
Yes.
no?
Yes, sir.
That means you want your y to reach a target value. How the y will reach the target value? By changing the x, isn't it? If I change the x by 1 unit, what happens to my y? Y moves by 0.5 unit. All of you understand what I'm speaking? X can be anything, y can be anything, isn't it? In your business process.
Yes. Yes.
Now, how should I optimize my x so that I can optimize my y, right? So that's the meaning. Now, do you want to see the regression equation for the first set of data?
Yeah.
Yes, sir.
Very good. So go to stat, go to regression, go to fitted line plot. Now you have this popping up, y variable, select the y variable, and x variable, select the x variable, click here and then select. Now, type of regression. Do you know for this particular problem, calorie consumption and weight gain, have we seen our scatter graph, scatter plot?
Yes, sir.
Yeah.
It was showing linear, right?
Yes, sir.
Yeah.
Yes, sir.
Yeah. And moreover, your R value also confirmed that. How much it is? 0.
9, 7.
Very good.
Okay.
With all this background information, you are choosing linear.
Hmm.
Now I am giving OK. And now the equation of the regression line also generated. Can you see here? One of you, can you read out this equation? Weight gain equal to?
Minus 754.6 plus 0.4631 calories consumed.
Now, what is the M value here?
Again, y is equal to m.
0.4631.
Can one of you tell me how can I use this or interpret this M value? What is the meaning of it?
That with every change in this m value,
Its impact is weak.
it is.
No, not change in the M value, change in the X value.
X value.
Or if you increase the calorie consumption by 1 calorie, what will happen to the weight gain? Weight gain will increase by
0.4.
0.46 grams. Am I correct?
Okay.
Then what is this minus 754.6? That will be
Yeah, that's a constant term in your regression equation. That is called y-intercept. That is called y-intercept. It means if I extend my line towards y-axis, where the line will cross the y-axis. See here, I'm extending this. Can you see my line crossing the y-axis somewhere?
yeah, below.
This point is known as C. This point is known as C. Can you see this point below 0?
Yes, sir. So minus.
That's why it is negative. You see here, it is negative. Correct?
Yeah.
So once you plot a scatter plot, you can generate the regression equation yourself also manually. So for that, you require the value of M, you require the value of C. How to get the value of C? Extend the line. See where it is crossing your y-axis.
Y-axis.
If you all have a graph sheet, I think we have suggested all of you to buy a graph sheet, isn't it? You must be having the graph sheet with you. And you can try this yourself. Take a scale and pencil, 15 centimeter scale and a pencil, and just plot this graph yourself. And then you will see all these things happening automatically. But Minitab is working like an assistant to you. It is doing everything. And now C is found to be minus 754.6. All right. Now what is M? Swapnil mentioned it as slope of the line, isn't it?
Yeah.
What do we mean by slope of the line?
Where the maximum.
Minus by a point.
One extra connection.
Impact in Y per unit.
We all
In
have
X.
might have studied in trigonometry. M equal to tan theta, isn't it?
Yes.
What is tangent of theta? Sin theta, cos theta, tan theta.
Sin by cos.
Sin by cos. Very good. Sin by cos. Instead of sin by cos, you can also say opposite side by adjacent side. Am I right?
Adjacent. Yes, sir.
You remember you all have studied this in your school days.
Yes, sir. School days.
Now you have to use all those intelligence to understand what is happening in your business. And now you see here. First of all, let us try to use this. Theta. Theta is straight away can be measured. Can one of you tell me how can I measure this theta? Can I measure this angle by using the 15 centimeter scale?
No, sir.
Okay, then how can I measure? Which tool I should use now? What is the name of that tool that we normally keep it inside the geometry box, right?
Yeah. That's it.
What is that?
Protractor.
Protractor. Very good. Use the protractor to measure the angle and then take the tangent. Take your scientific calculator and take the tangent. Now that will lead to 0.4631. That's all. All of you understand how this 0.46 is coming?
Okay, sir.
Alternate method. Shall I teach you alternate method?
Yes,
Later.
So alternate method is at any point on the line. Can you draw a horizontal? Possible? Possible or not?
Possible.
Possible.
Yeah.
Then draw a vertical. Now the length of the horizontal drawn is del x. Length of the vertical drawn is del y. You need to measure del x and del y. You need to measure del x and del y. Now find out the ratio. The ratio is nothing but del y by del x. What is this del y by del x?
Tan theta.
Very good. That is also equal to the tan theta. Because del y is nothing but opposite side, isn't
Opposite by
it? Yeah.
adjacent.
Del y is opposite side. Del x is adjacent side. Whichever method is convenient to you, finally you will be getting this value only, which is 0.46. But Minitab is doing all the job for you, isn't it? Right?
Yes,
So now all of you understand the regression equation here? Please tell me.
yes, sir.
This is no more a mathematics. This is giving you some
Yes, sir.
useful information to you. Right? And how to attack this problem, you are getting some input, isn't it?
Yes, sir.
Even if you are not a dietitian, you don't know what is calories, what is weight gain. but still after framing this equation, you get some insight about the kind of relationship calorie consumption and weight gain is having. And now if you come here, can you see something written here? Can you see something written here? All of
Yeah.
you? Yeah.
Yeah. Yes. Value.
One is S value, S is standard deviation.
Yes.
S is standard deviation.
R square
R square.
R square, and then there is one more R square, which is adjusted R
square.
square.
adjusted.
So for your model to be very good, the S should be minimal. The S should be minimal. So that's one thing. And R square talks about the sufficiency. How much is the R square here? 94%. This is what we calculated manually also, isn't it? Yes or no?
Yes.
R is square, and now it is R square.
Yes.
And the adjusted R square talks about the significance of the factor. Adjusted R square talks about the significance of the factor. The factor you are studying, is it really a significant factor? What is your understanding here? Is this calories consumed? Is it a significant factor? For that purpose, we go to session window and come here. Look here, this is the problem, right? This is the problem, or maybe in the correlation analysis itself. Yeah, here, hydrogen content. Oh, sorry, here. The correlation, weight gain and calorie consumed. How much is the p-value?
0.97.
0.000, right? 0.000, close to zero.
Yes.
That means it is factor is significant. Yes or no? Factor
Yes, yes.
p-value less than 0.05. We all know p-value, isn't it?
Yeah.
That means factor is significant. And so your adjusted R square is also confirming that. If you bring irrelevant factors, adjusted R square will decrease, will differ from R square. And adjusted R square differing from R square is not good for your mathematical model. We want to build a good mathematical model. For that, adjusted R square should be close to R square. And the R square should be above 80%. Now, in this case, is that both the conditions are satisfied? Adjusted R square close to R square?
Yes.
And your R square above 80%? That means your mathematical model is a sound model. Right? Whatever you understand by referring the regression equation, that will reflect the reality. Clear, everyone? Yes.
Yes.
And this regression is called linear regression. And this regression is called simple linear regression, because we are talking about only one factor at a time, isn't it?
Yes.
If multiple factors are considered, then your regression will be multiple linear regression. Now let us wind up this regression and talk about regression by generating the regression equation for the second case. What is the second case?
Hydrogen content.
Hydrogen content versus porosity, right? So let me erase all these things so that you can see the hydrogen content and porosity. So, okay, you can see the things now clearly. Now, please guide me. How should I plot this regression equation? One of you, where should I go? Should I go to graph?
Start.
Stat.
I should go to stat, right? Okay, then.
Regression.
Regression.
Fitted line plot.
Fitted line plot. Then here, y variable,
Height.
Porosity.
Velocity and
X variable hydrogen content. Now you have to choose a model. In this case, you are confused, am I right?
Yes.
Because we don't know whether it is linear. Why we are getting into a confused scenario? Simply because our analysis didn't go well, isn't it?
Yes.
We have missed certain important factors, and still we are trying to optimize our result, which is not going to be, easily possible. Am I right?
Yes.
You
Yes.
might get some improvement, but not the improvement you desire. If you want to achieve the improvement you desire, you must necessarily include the other significant factors. If you do that, your R square will keep improving. Am I right?
Yes.
If your R square goes above 80%, above 90%, you should be happy about your work.
Yes.
And then you try to implement the solution. Till the R square becomes 90% and above, you have to work in the analysis stage only. Don't jump to the improve phase. Don't jump to the solution. Jumping to the solution sometimes may not be fruitful. And the sufficiency is ensured in the analysis stage itself. Is that clear to all of you?
Yes.
Now,
Yes,
just
sir.
to demonstrate, I am choosing linear model here. But like all of you, I am also not very clear whether it is linear or whatever. But I am assuming linear because R square is how much? 0.625. I mean, R is how much? 0.625. I am giving OK so that all of us can see the regression equation. Can you see here? But now when you make all the statement, like 1 unit change in hydrogen content will increase 4.92 unit of porosity, you will be, the chance for you going wrong is very, very high. You know why? Your R square is very weak. Can you see here?
Yeah.
When R square is weak, the regression coefficient, this number is known as regression coefficient. These coefficient can mislead you. All of you understand?
Yes.
These coefficients can mislead you when your R square is insufficient. Clear?
Yeah.
Yes, sir.
So you need to work till the R square becomes at least 80%. If it is close to 100%, that's fantastic. If R square is achieved, achieve the R square by adding the significant factors. When you do both, adjusted R square will stay close to the R square. And please don't ask how this R square is calculated, how this adjusted R square is calculated, because some formulas are used. Am I right? Like R value, I have shown the formula. So this is called, the experiential learning. So people have already learned, understood. Whatever they have understood, they are giving it, they are passing the knowledge to you in the form of a formula. Who gave the formula for R? Pearson?
Pearson.
Yeah,
Yes.
he gave, right? He might have researched for several years, and then he understood something. And then he made it as a formula. And now either we should also do the similar research, or otherwise we can simply believe Pearson.
Accept it.
The best thing and the easy thing we can do is we can
Accept.
believe Pearson, and then we will use his name, and then we will tell this is the meaning. All of you understand? So,
Sir, one
Yeah.
more thing. In the C value, see if it is the line extended, it is coming more than 2 only. But it's showing as minus 0.59.
that is because, you have not included proper factors.
Okay.
Your R square is weak, isn't it? And when R
Yeah.
square is weak, it is better not to use this regression equation
Linear.
for
Linear.
interpretation.
Okay.
Don't interpret anything because the R square is weak. The regression equation, in your hand is not, an useful regression equation. That's what you need to understand.
Okay.
The data here, the equation here can mislead you.
Okay.
Good question. So these data files are available in Excel. I will show. Actually, I'm expecting the green belts here to work hard parallelly and master the subject. Can you all see the calorie consumption data here?
Yes,
Yeah.
sir.
I expect the green belts here and the black belts here to do the scatter analysis, to do the correlation analysis, as well as to do the regression analysis. And I want to see you, posting all these analysis in your LinkedIn profile and then tag me, right? Can you do it, all of you?
Yes, sir.
Very good, right?
Time and travel.
So, and I will issue a separate letter saying that you are, a sincere student in the green belt program or the black belt program. So that will definitely, sometime will be helpful. So that's all about correlation and regression. So any question anybody would like to ask, you can ask. See here, all the data I am using, I have again given here one-way ANOVA data, the two-way ANOVA data, two sample t-test data, and all the data files are available here. You can, the Garment effect for the Pareto, and you people can practice. Unless and until you practice after learning, and you can't really digest all those you're learning here. So once it should mix in your DNA, then only when required, you will be able to collect it and then use it. So much data is available, and if you could practice all the problem, many case studies related to the data, and then you are upgrading, right? All right, so I would like to stop here. That's all about correlation and regression, and the again advanced knowledge on correlation and regression will be continuing in the next session. So this is the green belt level. This is good enough. So RK sir, you can also summarize and about correlation and regression, and then in
Yeah.
after 5 minutes I can take them through the questions.
Thank you. Thank you very much.